welcome to video 2 of lesson 3. Now you're probably thinking after that last video that substitution stuff was pretty easy, but I know that not every system of equations is going to be set up where they are both y equals. Is substitution still something that I can use in other situations? And that's a good question to wonder, and there actually is a way that we can deal with that. We're going to look at one of the other situations right now, and we're going to continue to go through those throughout this lesson as well. So in example 2, we are given one of those situations that you're probably wondering about where we don't have them both in y equals form. Now we could go through the trouble of going through and putting them both into slope-intercept form, but we can actually go ahead and use substitution just the way these problems are right now. And it's going to hinge on the fact that I do have one of these variables solved by itself. So if you'll notice in example 2, I only have one equation where we are solved for a particular variable. In this case, we have the y. And the other variable, I have both my x's and y's on the same side in that equation. I'm still going to use the same substitution property, however. I'm going to go to the equation that is not solved, the 4x plus 2y equals 12, and I'm going to write that equation out. However, when I get to my variable that is solved by itself, which in this problem was the y, I'm going to replace that y with what y was equal to. So instead of putting the y here, I'm going to replace that with the negative 2x minus 1. And then I'm going to follow with the rest of the equation, equals 12. So all I did on this is I took the variable that was solved all by itself here, and I changed it out for what it was equal to, in this case, negative 2x minus 1. And again, the reason I'm doing this is so that I can get an equation that instead of having two different variables, only has one, and I can solve this out. So what I would do now is to go ahead and distribute this 2 throughout the parentheses. And that's going to give me a 4x plus 2 times a negative 2x is going to give me a negative 4x. And 2 times negative 1 gives me negative 2 equals 12. So I'm going to combine like terms, and I'm going to run into the fact that 4x plus a negative x is going to give me a 0x minus 2 equals 12. Now the 0x, 0 times anything is going to give me 0. So what this really is telling me is that negative 2 is equal to 12. Now, hopefully you recognize that negative 2 is not equal to 12. And hopefully you're also making the connection back to the last unit where we were solving systems of equations, and that you remember when we got two numbers that were not equal to each other and our variable canceled out, that meant that our problem had no solution. And that's going to be the case for when we're dealing with systems of equations too. If our variable cancels out and we don't have two numbers that are, and we end up with two numbers that are not equal to each other, then it is going to be no solution. All right. So let's look at one more example, because I want to illustrate the fact that it doesn't have to be the y that's by itself. If we look at example 3, this time instead of having a y by itself, I have an x by itself. So what I'm going to do this time is instead of replacing the y value, I'm going to replace the x value with what x is equal to. So again, I'm going to write the equation that the x is not solved for, but instead of putting the x, I'm going to put what x was equal to. In this case, negative 2y plus 5. So when I do that, that's going to give me a negative 2y plus 5 inside the parentheses. And then I'm going to finish the rest of the equation. Plus 4y equals 10. So I'm going to go ahead and multiply through. 2 times a negative 2y is going to give me a negative 4y. And 2 times 5 is going to give me 10. So 2 times 5 gives me the positive 10, and then I still have the plus 4y here, equals 10. So I'm going to combine my like terms, my negative 4y and my positive 4y, and that's going to give me 10 equals 10. And you will again see that my variables canceled out. However, this time, instead of getting two numbers that weren't equal to each other, I got two numbers that actually were equal to each other. And if you think back to what that meant in our just solving equations, that meant that we had infinitely many solutions. And that's going to carry over into this problem as well, into our systems. So I would say infinitely many solutions. So just a reminder, if you do end up with your variables canceling, if your numbers end up to be the same, it's going to be infinitely many solutions. And if you get two numbers that are not equal to each other but are claiming to be, it's going to be no solution. Alright, we do have a couple of U-Try problems for you to attempt. Make sure that you check your answers on the webpage or the key in class, and then come back and see us in the next video. See you then.